if you don't know, I have a short introduction to each technology. So, I lost my screen. Yeah, it is for the demo. I need to zoom in. Yeah. So let's start. So tonight we are going to talk about DSE Max, how to use Spark with Cassandra. So, well, the introduction has been done, so just skip. Datastax, who are we? We are the biggest contributor to Apache Cassandra, the open source project. In fact, 80% of the Apache committers, they are employees of Datastax. And what we do is we support the community and we provide also, of course, Datastax Enterprise, which is an enterprise version of Apache Cassandra. You take the open source product, you add a lot of features. So let's talk about Apache Spark. The project has been created at Berkeley, the university. The idea of Apache Spark is to give you a general data processing framework, okay, which is faster than Hadoop because all your data are staying in memory. Who is familiar with Hadoop here? Okay, you know that with Hadoop, between each job, the data are written on disk, right? So with Spark, the data stay in memory. And the second idea of Spark is to have one core API, one core component, and many plugins, okay? You have plugins for streaming, you have modules or plugins or whatever you call it, for SQL, for machine learning, and all of those modules, they are just relying on the core API. So, some basic example, how you can set up a Spark job. First, create a Spark configuration. Here you set your application name, the master. So basically, on production, you should set an IP address here. Now I'm using Spark on my laptop, so it is local. This is the local mode. From this configuration, you will create a context. Now, before processing data, we need to fetch the data somewhere. So let's just create some random data, okay? Here we have a list of 3 people. It is a triplet of user, okay? Login, name, and age. From this list, we call the method parallelize people. It will give you an RDD. What is an RDD? Well, resilient distributed dataset. From this RDD, you can perform many actions. Map. So basically what I'm doing here is from my tuple, I extract the age, okay, which is tuple underscore 3, because the age is at the 3rd position. And from this, I perform a group by, so I want to group all those people by their age. And then I want to count by key, which is give me the number of people for each age. Okay. Very simple. Now, what is an RDD? You can see an RDD as a distributed collection of what? Of something. It can be a person, a class, a tuple, or whatever you want. Okay. And the idea is I have a distributed collection. So I want to split this collection into partitions. A partition is a chunk, okay, of your collection. And why should I do that? Because if you have many chunks of your collection, you can send them to many workers to allow parallel computing. So on each RDD, we have direct transformation, map. I want to transform my object A into another object B, whatever A or B is. Filter, and so on. So simple transformation. We have also special transformation which will require shuffling. What is shuffling? Shuffling means that, okay, once you have sent your partition on many machines on a cluster, shuffling means that all those machines will send the data on the network. So it is very expensive. Some operations like group by, reduce by, or join, on those operations there is no magic. You need to shuffle data, okay, to group them by a key or whatever. And the last kind of things you can do with RDD are actions. So until now, even if I call map or group by key on my people, my RDD of people, nothing happened. All the transformations are lazy. Okay? And until I call the action, nothing happened. When I call the action collect tag for each, this will pull a chain of dependency. So when I call count by key, the group by age will say, oh, where are my data come from? It's come from extract age and so on. It will climb up the chain of dependencies and compute all the child RDDs. So here is a very graphical view of what is happening. Each rectangle is your partition. The white rectangle with dotted lines, this is your distributed collection, right, RDD. So you have direct transformation. Shuffling will send data all over the network, expensive. And then final actions. So here is the architecture of Spark. On the bottom you have persistence. Spark is a data processing framework. It is not a database. It means that you need to provide the source of your data somewhere. It can be from Cassandra, it can be from HGFS, the elephant here. It can be from a flat file, a CSV file. Okay. There are many connectors to, well, whatever you want. Connectors to HBase, connector to MySQL. On top of that, we have the cluster layer. To be able to manage a cluster of Spark, either you can run in local mode, so on one laptop like this, on one machine. You can run a standalone cluster where you have a master and workers, or you can use the YARN resource manager of Hadoop or Mesos. Now on top of this cluster layer, we have the core engine, the blue rectangle. You can use Scala, Java or Python as languages. Who is familiar with Scala here? Fine. And as I said, on top of the core engine, you have components, streaming, SQL, graphs, machine learning. Tonight we are going to focus only on those parts. Okay. A very quick introduction to Apache Cassandra for people who don't know. Project has been created at Facebook. This database is a NoSQL database, of course, and it is an AP database. So for those who know the CAP theorem, A is high availability, P is partition tolerant, C is consistency. So out of 3 features, you can only have 2 of them. Right? So Cassandra chose the high availability and partition tolerant side. All the NoSQL database choose the CP. Okay? And with Cassandra, what you have is a distributed table. So imagine in the classical relational world, you have a table, right, with primary key. In Cassandra, you have a table, but this table is distributed all over the cluster. How does it work? Well, every time you send data to Cassandra, you need to provide what we call a partition key. hash partition. A partition key is like a primary key of your table. And Cassandra will apply a hash function on this partition key. It will give you a token. So of course, the range of all possible hash values is very large. Okay, it is a huge number. The idea is, if I have 8 machines in my cluster, Cassandra will split this hash range into 8 equal intervals. And if I insert the data, Cassandra compute the hash, give me the token. If the token is in the D interval, Cassandra will assign the data to the node D. Okay. So intuitively, if we choose a very distributed hash function, we can guarantee a uniform distribution of data on the cluster. And thanks to this hash, we can have linear scalability. Imagine I have a table called users. Right? So my partition key is user ID, of course. I have many columns. First name, last name. A partition is just a physical line, right? So each user represents a partition. Thanks to the hash function, Cassandra will distribute those data all over the cluster. So it doesn't matter if you have 1 billion, 2 billion of users. The more you have data, the more you add machines, and the more Cassandra will rebalance data automatically for you. Last thing on Cassandra, which is the query language. So to access data in Cassandra, you will use CQL, Cassandra Query Language. So as you can see, it is very similar to SQL. The idea is to close the gap for those who are coming from the relational world. Okay. Now we can get serious. So how can we integrate Spark and Cassandra together? Well, by using a connector. So almost 1 year ago, Datastax, we open sourced a connector. I'm going to show you how it works. So the idea is, with this connector, we are using the Java driver underneath. We expose Scala and Java as languages, not yet Python. And with this driver, with this connector, you can perform server-side filtering with SQL. So for the Spark Core API, what we can do is, you can read data from Cassandra into Spark, and you can write data from Spark into Cassandra. Okay? And the mapping of the Cassandra tables and rows, well, we just provide those classes, Cassandra RDD, Cassandra row. If you want to work with Scala case classes, so for those who don't know Scala, a case class in Scala is basically a Java bean, a POJO with a getter, etc. That's it. So we have an integrated object mapper for you. And if you want to work with tuples, we also support them. Okay, some demo. So instead of, normally I plan to show you my code in this IntelliJ, but I found a better way. So this is the web interface. This is an Apache project incubator, so it's not even released yet. But it provides a very nice web interface. So how can I write data into Cassandra? Well, 2 things. First, you need to import this class because it contains a lot of Scala implicit. You start a Spark configuration. You must set these parameters. Of course, you need to provide some IP address for the connector to contact the Cassandra cluster. Suppose we have this table, okay? I have found on the internet some statistic about the unemployment rate in the USA. Fine. So Europe. So suppose we have this table in Cassandra. First, I reset the table. So I do a truncate. Okay. I can check The display is so bad. Okay, it's better. Nothing, right? No data. Now I will load some data from a flat file, CSV file, on my disk. Okay, a very small file. From the Spark context, I will read this file, zip with index, whatever. I will remove the first line because the first line of a CSV file is just the header, the column header. So I'm not interested in saving the header into my Cassandra database. And for each line, I need to split by the comma. And I need to convert each data into the appropriate type. To int, to double, and so on. And save to Cassandra, Spark demo. So the first parameter of the method save to Cassandra is the key space. So for those who don't know, in Cassandra we have tables, okay? And we have key space. A key space is just a table container. In one key space you can have many tables. So if you are familiar with Oracle, in Oracle you can have a schema and then many tables. Well, the equivalent of the schema, Oracle schema in Cassandra is key space. So I asked Spark, please read this file on disk, parse it, and save it to Cassandra, right? In this key space and in this table. And of course I need to specify the columns. Why? Because the connector, he cannot guess. He cannot know that this first data correspond to this column, the year, and the second data correspond to the civil non-institutional count. So it is very boring every time you need to specify all those things, right? Another solution is you can write to Cassandra using a case class. Remember, case class is Java bean. So I define a Java bean case class here. And the same thing, instead of just having a tuple, I have a case class saved to Cassandra. And this time, as you can see, I do not need to specify the columns, right? And the connector with its object mapper will match each property of my case class to the Cassandra column automatically for me. So let's run it. New effect. Okay. Right. Now, writing data to Cassandra. Easy. Next step is how can I read data from Cassandra? Because okay, it's fine to dump data in, but I want to use my data. So 3 ways. First, you can use the plain Cassandra RDD Cassandra row, or you can convert the Cassandra row to tuples, or you can use case classes and object mapper. So I have a table, I reset the display, okay. First, I use Cassandra row. So here, Spark context, Cassandra table, key space, table name. This is equivalent to select star from Spark demo.us unemployment stat. So I fetch all the columns. I collect, and for each column, for each row, I will extract the year. So row get int year. Please remark that every time I need to specify the type of my column. Right? Get int, get double. and then I just append to a string so that I can display. This is very boring because every time you need to know the type. See? Data. Second way to do is to use tuple. So this time, instead of doing a select star from, I only select some columns which are interesting for me. Year, unemployment percentage, as, so I tell the connector that the first column is an integer, the second one is a double. And then, of course, I can sort and so on. So I reset the table display, run this second code, done. Okay? Let's move on. So you can write data into Cassandra, you can read data from Cassandra. What about Spark SQL? Well, we also support Spark SQL. We introduced Cassandra SQL role, which extends the Spark role. The idea with Spark SQL is every time you perform an SQL query, the Spark SQL engine will transform it into a map filter, into the core API, with a query plan. They have an integrated query planner. And what we did with our connector is we extend this query planner. Why? Because if we see this query, we can realize that the login predicate, where login equals John Doe, this predicate we can perform it with SQL. So we can push this down. The more you filter directly from Cassandra, the better it is, because you will fetch only a small amount of data. Right? So we push predicates to SQL whenever possible. Sometimes it's not possible. Okay, in this case we fetch all the data in memory. So using Spark SQL, here, first you need to create a Cassandra SQL context from your Spark context, and then you can do a Cassandra SQL query. So if you are not a developer, if you are a data scientist, and if you are only familiar with SQL, you still can use Spark, very easy. Select. So I want to select years and employment percentage only for the years where the percentage is bigger than 8, right? So as you can see, this predicate cannot be pushed down to SQL because we don't have secondary index or anything. So in that case, Spark, the connector, will fetch all the data and perform the filtering in memory. Okay, so here are the years where the unemployment percentage is greater than 8 in the US. Simple. Oh, Spark streaming. We also support Spark streaming. So there are two ways to stream data. The first thing is you have a source from an external source, okay, of data. You can stream data into Cassandra. It is trivial. I can show you. Be careful about your data model, because since you have an infinite stream, if you store all of the data on the same partition, it can grow indefinitely, so be careful. What about streaming data out of Cassandra? Well, if it's about just reading the whole table and put them into a stream, it's not very interesting. We can already do this with the Java driver. You can have server-side paging. What we want to do is some kind of notification system. It means that you create a Spark stream, and every time you have an update or mutation in Cassandra, it will notify the Spark stream. But to implement this feature, we need some kind of trigger. And triggers in Cassandra is a tricky business. So we are working on this. We want to make it reliable and performant. So right now it's not yet available. Some demo. So I couldn't make it work with my web interface, so we are going to do it the old way. So here I have a Twitter stream, okay? I have a Twitter account. I want to listen on Twitter, all the tweets. And I split them by white space, and I only want to keep the tweets which have those keywords: love, hate, happiness, and sadness. Okay, simple, very basic things. And then I save into Cassandra. So if I execute my application, okay, it's running. Say let's start from Twitter stream. Nothing. Oh, I already used. Oh, I know what happened.
You need to stop server.
To stop server,
Zeppelin.
yeah. I love my Zeppelin. Okay, sorry Zeppelin. You are going down. Sorry, that's life. Hey Zeppelin, okay. Stop. Okay. No, not this one, not this one, not this one, not this one. Okay. Some love, one love and one sadness. Okay, that's life. Some more love. So every 5 seconds, I take a snapshot, a picture of what is happening on Twitter, and I just throw it into Cassandra. And as you can see, the interval column capture also the date. Okay. So we can see that right now there is a lot of love and joy on Twitter. Some sadness, some hate, but it's fine. They are minorities. Yeah, lots of love. Fine. So just stop here because we can continue forever. Okay, so this is streaming. Easy, trivial. Any questions so far? Yes.
How does memory crash is handled? Because Cassandra is moving to put a lot of stuff off heap, and Spark processes everything in memory. So if you read a full table into memory in all the servers, so
Yeah, excellent question. So what Cassandra in fact used not that much memory. In fact, the system memory used by Cassandra is for page caching, right? Some flat files are put into the OS page cache for faster access. But if they are not put into page cache, still we can read them from disk. It's not a problem. The real problem is Spark. Spark like a lot of memory. And of course, if you are reading all the table into memory, and if you have a 10 terabytes of data in your table, yes, you are running into trouble. But thank you for asking the question, because it will introduce my next slides. Any other question? Yes, please.
Yes, you mentioned that Spark can run like in several modes, it can run locally, it can run standalone. Are there any plans to run like in the same GVM? Like, you know, like Cassandra, we can run it in the same application, same GVM.
Right now, not really. Why? 2 reasons. Because first, the connector and the data locality we can achieve is very good, so there is no big requirement to have both process Cassandra and Spark in the same JVM. Second reason.
No, I'm not talking about Spark and Cassandra, but I have an application, it's already distributed, and it's running in our own infrastructure. And I do not want to introduce like separate infrastructure like Yarn or Spark. I just want to run Spark libraries inside my own instances. So
Yeah.
embedded, like embedded.
You can Yeah, you can run a standalone mode. Yeah. And that's what the mode we recommend.
It will still find each other. It will still find instances of Spark.
You will have a Spark master, you have a Spark workers. Yes.
Is it a part of your application? That's what you mean.
I mean, it's like Elasticsearch, if you had...
Embedded.
Yes,
No, I
yes,
don't.
Yes.
Multiple nodes, and
It's in the. In fact, you can, if you are, because Spark master or Spark worker, they are just, well, they are Scala classes, but yeah, it is just a class. It is just a bytecode at runtime. So yes, you can embed. It is a little bit tricky technically, but yes, you can do. We did it. I will show you how.
But-
Yes.
And in relation to this question, for example, how do you normally, for example, the Elasticsearch, automatically a master is being assigned, and the master, it's all done, the whole cluster management is automatic. Oh, I don't think that's possible with
Spark.
Yeah.
Yeah.
Because
Spark.
normally you need a zookeeper that assigns.
Yes. Excellent question, which will be answered in the last part of my presentation. Everything will be covered, don't worry. Okay, let's go. So operation. Let's get our hands dirty. So how do we deploy a cluster with Spark and Cassandra? We recommend this deployment standalone, no yarn, no dependency on Hadoop, no mesos. The idea is, on each machine, when you have a Cassandra process, you need to have a Spark workers process. And of course, you need also to have a Spark master somewhere. On the right, this is the three-dimensional view of what is on the left. So you can see on the same machine, one column is one machine. Okay? Cassandra on the bottom, Spark process on the top. So how does it work? We want to have a one-to-one relationship between the Cassandra process and the Spark workers to guarantee data locality. So here I have 4 machines, 4 Cassandra process, 4 Spark workers, and 1 Spark master sitting around. First, I have my Spark client, my driver program. A driver program is this. This is a driver program. This piece of code is my driver program. Okay? It is where I define my business logic. That's all. Just a question of vocabulary. Spark complexity. First, I start my Spark job. The client, the Spark client, will send this job to the Spark master. Hey, we have a job. Please give us some resource. The Spark master will dispatch this job onto 3 workers, okay? If they are not busy. Each Spark workers will create a Spark executor, which is like a context inside which your application will run. So if you have 2 Spark applications, each of them will run into separated executors. So there are some boundaries, okay? And of course, if you are accessing data, each executor, Spark executor, will communicate with the Cassandra process using the Spark connector. Right? Remember the token range I introduced for Cassandra. Well, to provide data locality is simple. With Spark, you have partitions. Okay, partition is chunk of your distributed collection. Well, if we map Cassandra token ranges to Spark partition, what we can provide is just data locality. So when the Spark worker here on the red node is asking for data from this partition, in fact, the data is just on the local node. This is the idea. So when you are reading data from Cassandra, the read is local. It will not go everywhere on the network. So if you have a 10 terabytes of data, table of data, and if you have 10 nodes, each node will read approximately 1 terabyte of data, right? Because it is distributed. Of course, once you are in memory, you can perform some operation. Some of them will require shuffle, joins, group by. So after a shuffling, you lose the data locality with Cassandra because you are moving data around. So you lose the matching between a Spark partition and Cassandra token ranges. Okay. And after that, after a join, if you want to save your data back into another Cassandra table, well, the data locality is lost, right? So the connector will just send batches to everywhere, to many nodes. Or you can call this method we provide in the Spark connector. What it does is, it says, okay, please, Spark, please shuffle again my data so that they will match the Cassandra token ranges of my target table. And after doing this repartition, if you write to Cassandra, the write will be local. There is no magic. So, in both cases, either you don't repartition before or you repartition before, there will be data moving on the network. There is no magic. Okay? But it is a little bit better to do like this, because you may save some network bandwidth, whereas here on the right, it will fan out on every node. We can perform joins in Spark with data locality. I have a table artist. My partition key is name. I have another table album. Partition key is title, and I have an artist column, which is obviously a foreign key, a join key. So what I can do is, from Spark, I fetch all the album. I select the artist and the year, and before joining with the artist table, I force Spark to repartition those data with respect to the token range of the artist table, so that the join will be done locally. So let's see how it works. Read from Cassandra locally, shuffle, repartition to map Cassandra token range, join with data locally. Another round of shuffling, force a repartition before saving data back to Cassandra. Okay. There is still one use case where you can have a perfect data locality, no data on network. It happens when you are using very simple transformation, map filter, no joins, no group by. In this case, you are reading data locally from Cassandra into memory, you are transforming your data, and you are writing your data back. Simple. The use case is, oh, I want to fix some error in my data set. And it works. How can we handle failure? Imagine, as the mister here asked the question earlier, imagine, boom, I have too many data. I don't have enough memory. I lose one machine, right? So the Spark master will reassign this task to another worker. But in this case, I may lose my data locality, right? In fact, not really. Here, this is an extract of the RDD interface. An RDD is just an interface, okay? And people just implement this interface. And in the connector for the Cassandra RDD, we implement this method, get preferred location. So if I give you one Spark partition, please give me back the IP address of all the machines who carry the data for this partition. Well, instead of returning just one IP address, we can return a list of IP addresses which correspond to the replicas, right? Because if you have a replication factor bigger than 1, well, you can return a list of IP addresses. And if your job your node fails, Spark will choose the next preferred location, which is another replica. So you don't lose data locality, in fact. You need to tune those 3 parameters carefully. Okay. People often ask me, if I have 2 data centers, how can I read data from one and write data to another data center? Well, there is a trick. It is not in the document, the official documentation. You can create 2 Spark configurations, one for each data center. Right? You read data from the first configuration, because I create my Spark context here with the first configuration, and you save to Cassandra using the second configuration. Okay. The same for cross-cluster operations. If I have 2 distinct clusters, I can use the same trick. Any questions so far? Yes.
With Spark 1.2, there's an addition of walls,
Of what?
write ahead logging.
Yes.
So in that case, if you go back 2 slides, where you said that when one of the nodes goes down, so when you have a write ahead logging, and you can store that into a file system such as HDFS, then in that case, how does this architecture change?
Excellent question. In fact, I didn't dig into this write ahead logging, to be honest. So I cannot. I think the write ahead log is here for if you lose one node, you can still retrieve the data, right? But this logging is it for streaming or on? So it is for streaming.
Yes.
So if you are not using streaming, you are not really impacted by this write ahead log. But for the case of streaming, I don't know, to be honest. So I will have a look into this. There was a question here.
I have a question about virtual nodes and the partition size. Of course, RTDs and Cassandra, they both have a notion of partition,
Yes.
but they don't need to be the same size.
No.
So what happens in fact if, for instance, the partitions in Cassandra are not as big as the partitions in Spark?
You can have a one-to-n relationship here.
Oh, okay.
You see, one Spark partition can map to many token ranges. And there is a parameter to configure this with the Spark connector. Some other question? No? Yes?
One question on your example with the local data reading. If you're using read core, how that do?
No, by default, we are reading local 1.
Okay.
Of course, if you are reading red quorum,
Then
Yeah.
it would be a mess, right?
yeah, there is no magic, sorry. I'm not a magician. We try to optimize as much as possible. But yes, if you are reading with quorum or something bigger than 1, yes, you will lose all the benefit of those things, of course. Yes, yeah.
With does Spark decide to read from Cassandra to replace the data?
With what?
When does Spark decide to read data from Cassandra? Is that when you execute a query, or is that refresh every time?
There is no refresh. So, Spark context Cassandra table, it will read only one time.
When?
When you execute the final action on your RDD.
So you said that it's better to shuffle data again to ensure data locality before write to Cassandra. But
Yeah.
why? I mean, Cassandra already does it. It just shuffles data. You can write to any node, and if you
Yeah, but still you can write to any node, but they need to be a replica. So here you see, if I have replication factor of 3, and if the data, because after shuffling, the partition key of what is on this Spark workers may be here, 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 or everywhere. Or you can go through a coordinator which will stream data again. So
No, it's just the same stream, so you move data from, you move like data inside Spark, you move data inside in Cassandra nodes, it's just one stream, so I mean, why is it more efficient to move data before writing to Cassandra?
Spark has you have compression and they have serialization, which is a little bit better. Let's move on. I'm running out of time. Use cases. Okay. How can I use Spark with Cassandra? 4 major use cases. The first one on the left we have seen already. I can use Spark to read data from any source, flat file from the cloud, and dump those data into Cassandra. I can use Spark, well, to clean up my data. Suppose that you have a bug in your application, or you have dirty data. Well, just use Spark to clean that. I have a demo here. Data cleaning. Oh, yeah, I need to Spark. Stuck. Exactly. Okay. So, my original data is, I have the table performers, okay, which represent all the artists. And each performers, as you can see, they have a country of origin, they have name, they have their gender, they have the born date and the die date. The problem is, the die date is, the date are not normalized. What? Here. Sometimes some people provide the year, months and day. Some people give just the year and months. Some people just give the year. So my date are not normalized. How can I do? So I can create just a Spark job, some pattern matching with regular expression, right? So here I'm reading data from my table into my case class. I cache them in memory, and if it matches this pattern, if I have only the year, well, I will add 1st of January by default. If I have only the months, I will add the 1st of the month by default, and I save back data into Cassandra. Okay. Okay. Now, if I read my data back, display up. Oh, you see? All the data have been normalized. And 2 lines of code. If you see, well, 2 lines. A little bit more. So, data cleaning. Schema migration. I have designed a table for Cassandra for my business use case. 2 years later, my business will change. I need to migrate my data, right? Use a Spark job. Spark job. So, I have my album table. The partition key is the title of the album. So I can access my album if I provide the title. Now, if I want to search my album by country and by year, I just can't do that. So, I want to create this table, album by country, where the partition key is country and year, and order them by title. Okay, this table first. So what I can do is very simple. I read the data from the source table. I save directly to the target table, 1 line. Of course, here it is a simple use case where you change just the key, the partition key. In some case, you need to join data. Okay, still. We have seen already the join use case. Very easy. Okay. Just run. It will just copy data. This is not multi-threaded. Okay, now search. So now I want to search my data by country and year, you see. I want to fetch all the album released in this country last year. So maybe you know better than me the music in this country. Okay. I have a very small data set, of course. I don't have all possible albums, right? Okay, data migration, analytics. Another nice use case. What if I want to know the top 10 most common music style for artists? I want to know if rock artists are the most common or not. So, in fact, we can have an analytics pipeline. The idea is you are reading data from your production tables, okay, designed for high performance. You read those data with Spark, you aggregate the data with Spark, do joins on whatever you want, and you save back data into dedicated tables for fast visualization. And that is the pipeline. Okay. So, where is my pipeline? Analytics. Reset data. Compute data. So, I have a top style. Top 10 style. Oh, sorry. I show you the how to display it, but I forget to show how to compute it. Yeah, it is the original code. Sorry, it is very low level. So, select all from performance distribution by style, where style not unknown, of course, I'm not interested by unknown style. And group of artists or solo artists. Okay. So I will fetch all the style from group of artists and solo artists. I cache them. For each of them, I drop the top 10 because they are sorted already. There is a sort here, sort by count. I drop the top 10 and I sum up all the data, all the counts for the remaining tail. This will give me the others, okay, others group. And then I merge with the top 10 for solo artists and group artists. Okay. And then I say back to this table. And now if we want, here we are. Okay, you can have display like this. Right. More analytics with Spark SQL. The same thing, the same code I can do with Spark SQL. Here, select compute decade. Okay. So this time I want to know for each decade, 90s, 70s, 80s, for each decade, and for each country, the number of album released. Okay. So this is the big query with join. See, country not known, country not unknown. Of course, I filtered out all the years before the 19th centuries, group by decade in country, having, so it is a very complex query. I perform this and I save to a table. Oh no, I don't save, I just build a result. Let me check. So let's run. It will take some time. Why? Because this time, as you can see, each predicate here is not possible to push them down to SQL because it is inequalities, they are range predicate. So what the connector will do is to fetch the data from each table into memory and perform the filtering and the join into memory with Spark. Okay. So how long does it take? Interesting to have 32 seconds.
How big is the data set?
Not that big, 400 megabytes.
Is it only force time?
Sorry?
Is it force time pixel if you perform the query? Only force time. If you perform again the query,
Yeah, it will refetch again the data.
But the data set RDB is cached, right?
It will be somewhat faster.
Yeah.
Yeah.
If you change only some parameter, like the year, then it will be faster.
Yeah.
But it's not
Yeah, I need to cache it. Yeah.
very fast.
And here is the display.
Only goes 50 seconds.
Okay, so we can see that in the. Why is it so small? Wait. Something buggy with this. Wait. Okay. So we can see that in year 2K, most of the albums are released in USA, of course. Again, my data set is small, so it's not very representative, but still, you can see what kind of analytics we can do with Spark SQL or with the plain Spark code. Okay, analytics. Now, until now, I was just talking about Spark open source connector and open source Cassandra, right? Now we are going to talk about DSE. So the typical production deployment with DSE is, this is the recommendation. You have your live data coming into a live production data center, and you have another data center dedicated for analytics. So even if you are losing some nodes because there are too many data, you don't have any impact on your production. So to set up, you have some configuration files. We introduce a spark.sh where you can configure all the Spark parameters. Oh, we have one formula for the sizing of the heap of Cassandra.
So can you go back on? Okay, so basically it starts two different environments. Okay.
Yeah, on the same machine, DSE will start the Cassandra process and the Spark process.
Separately.
Yes, separately. So this formula is very well known. It is given in the Cassandra arm.sh. You can override those parameters manually, of course. For the Spark memory, well, you must know that the Spark master is very lightweight. Okay, it's a tiny piece of code. The workers and the executor require much more memory, of course, because it is there where your application code will be running. So in the DSE YAML file, you can specify a ratio. This ratio is used to assign resources, memory resources between Cassandra and Spark. So this is the formula. The same thing for, of course, for Spark you can always override those settings yourself. The same thing for the number of cores, CPU cores. You use the ratio or override yourself. Some important tricks to know. In theory, one Spark job runs inside one Spark executor, and each workers can have many executors. One executor it's okay. One executor is dedicated to one job. But in a standalone mode,
It's 9x.
Yeah.
But in the standalone mode, what we have is, there is a Spark Jira here, there is a bug. One Spark worker cannot have more than one executor. So if you have many jobs, if you want to run many jobs in parallel, you need to start many workers on the same machine, in the standalone mode. change this parameter. Oh, memory. Of course, the more you give memory to Spark, the better it is, but be careful about GC, garbage collection, of course. Spark is a Java technology. And let enough memory free for the OS page cache for Cassandra, of course. Otherwise, you will hit disk every time, unless you are running on SSD. Yes?
What about Project Tycoon that stores RPDs of a heap? So the company, the research center that developed Spark, also is working on the off-heap data storage solution.
Yeah.
And so they're using it for the caching of RPDs off-heap
Off-heap, yeah.
instead of the destinations.
But still, it will use your memory.
Well, it would use memory, but it would use part of memory that would not be affected by garbage collector.
Yeah. Be careful also, before going off heap, you need to be on heap first.
Well, obviously.
So, anyway, data is coming from some source. It's coming on heap, and then it's moved off heap. So, the time it comes on heap, it will consume some data. So, yeah, but of course, it will improve somehow the performance. For the crosshair, yes, there is a very famous pitfall. When you start a Spark stream, it will consume one core. It will block on one core and listen for data to come in. So if you do not give more than one core to your streaming job, well, it will not start, because one core will be used by the stream and there is no core left for the job to be executed.
So,
yeah.
Pinning is useful. Resource pinning is useful, or it should not be tried.
What is the resource pinning?
So you pin certain process to certain cores, so that they don't spread around and you avoid.
Well, it doesn't matter, because if you say when in your Spark configuration for Spark executor, I give only one core, the core will be used by the stream. And if you assign this core to a job, well, the stream will not start. So anyway, your job will fail. And if you do not have enough resources to run jobs in parallel, you can run them one after another. And I think I have. So, any questions so far? Okay. I have just enough time to talk about the big data platform. So the idea at Datastax is we want to give you an integrated platform, okay, where you don't need to pull out many different pieces of technology and connect them with a cable. And so the idea is to give something well packaged and well integrated. We already did this with DSE search. The idea is, you don't know that with open source Cassandra, it is very hard to perform full text search. It is impossible, right? And we did an integration with Apache Solr. So in the same JVM, we embed the Solr source code, so that we can extend the SQL syntax for Solr query directly into Cassandra. So some demo, I think I have a demo here. DSE search in action. So select performer title year from Spark demo, where I want to fetch, sorry, this should be removed, all the albums where the performer names is Jackson. So Michael Jackson, Janet Jackson, something. So see how fast it is, 2 seconds. Okay, the Jackson 5, Michael Jackson, Janet Jackson. And if I want to take, for example, this song, I can just add this predicate, title contain extra. And you can perform range query on the years, many things. And it is integrated directly into SQL. So yes, question?
Does it also support like facets and all
Yes,
kinds of other?
for with the release yesterday 4.7, you can inject here. In fact, you can inject a JSON query as if you are doing with Solr.
But also in return stuff. So for example, in return sets, you can also ask for all facets, etc.
Yeah, you can do faceting. I have read it on the documentation that you just released yesterday. So faceting works also, yeah. So this is Solr, so simple, it works. Now, we have seen already open source Spark. With Spark you can do lots of interesting things. And now, with yesterday release, Datastax Enterprise 4.7, we just combine the three technologies together. Full text search with Cassandra and analytics with Spark. So why? So it will give you what we call the big data platform, blah blah blah. But in fact the idea is, you mentioned it before, what happens if I don't have enough memory? Well, money, spend money, buy more money. Okay, buy more memory. Or you don't have much money to waste into lots of RAM. You must filter your data the maximum since the beginning directly from Cassandra, so that what is going out of Cassandra is a very small data set. Because when you have a 10 terabyte table, well, it's impossible to fetch all of them in memory, right? So filter the maximum data with DSE search, Solr, fetch small data in memory, aggregate with Spark. And if your query, if your search, if your filtering criteria are restrictive enough, you can hope to do real-time analytics, near real-time. It means that you don't need to run a batch which will last 1 hour. You can wait for example, less than 1 minute. If the criteria is restrictive enough, again, there is no magic. Okay? Oh, how to preserve data locality? Because we add another component into the box, right? Well, there are 3 ways of doing it. First solution. From the driver program, imagine if I have a separated cluster of Solr. I will first perform a full text search, asking this whole cluster. It will find out, retrieve a lot of IDs on one machine, and then use those IDs to ask for Cassandra. Another way to do is, inside each Spark workers, I will issue a search request with restricted routing to each of the Solr node here, but still, again, a lot of network traffic. Or you can do this from the Cassandra side. Imagine people say, oh, I have a connector for you. You are using Cassandra. I have a connector with Solr. Okay, just plug in, but the connector is just a cable, right? So this will happen on your network. That is why, well, and the drawbacks of those solutions. And here we see the advantage of having same JVM integration is that you don't have data going around on the network. And the search is done locally. There is no need to, find out and ask every node, hey, where is my data? Why? Yes?
How do you do distributed search then, for example?
You don't know? Let me show you these things. Because when you, this is in the context of Spark and Cassandra. It means that you use Solr to filter data and then use the data by Spark. If you do just simple distributed search, it will find out. There is no magic.
Yeah, for example, if you do for select count star, of course, with a very large table, you want to count all the records, and you need to find out and need to aggregate also the search account.
Yeah.
Search nodes.
Yeah, there is no magic. In this case, you are not doing any the count star scenario is the worst scenario,
Yeah.
and you better use counters for this.
Right.
But for example, I want to perform some joins, some big joins on big data set, but some filtering. This will come in handy. Because what happened is, for example, this. I want to select the artists, the albums, okay, which have rating bigger than 3, style rock, join with another table, join with the artist table. I want only to select the artists between 20 and 30. So what happened is, since it is distributed, the Spark connector will generate this query. So you still have the Solr query predicate for full text search, but this time, this will be restricted to some token range. And in fact, this restriction turns out that the Solr query will be done locally. Okay.
Question. Say, okay, is everything on the same JVM now? So,
No. Solr and Cassandra inside same JVM, Spark is on another JVM.
okay, but still, garbage collecting can be worse now.
So you better have
Memory.
memory. But less than if you have just all the things in with Spark. Of course, there is no magic. Instead of having like 200 gigabytes of memory, you may extend by. Of course, if you embed another piece of framework, piece of technology, you need to have some more memory.
But there is any guidelines on because tweaking the Cassandra, the JVM, tweaking the JVM for Cassandra is already tricky enough. So with the added Solr, how much complexity does it bring?
How much?
Complexity does it bring to
It
the...
depends on your workload. The thing is, tuning JVM is an art of itself, and there is no answer. I mean, if you're doing simple query, simple search, and restrictive search, well, on a very small system, like if you can give only 8 or 16 gigabytes for Solr and Cassandra, it will work. If you are doing queries which are not restrictive enough, well, the bets are off. Of course, it's life. And yes, and this thing is you can scale, because tomorrow, if your data set is multiplied by 2, you double the number of nodes, but still the processing time is approximately constant, because again, the filtering is done locally. Yes.
A trick question. For example, with Solr, there's a lot of configuration. I think sometimes you need to restart Solr. Can you do a rolling restart using the DSE?
Yes.
Yeah, because else you need to do a full cluster restart, which is sometimes.
Oh, in fact, what I didn't tell you is what we did is we forked Solr. Right? Solr is a master slave. And when we embed Solr into the same JVM as Cassandra, in fact, Solr will benefit from the dynamo layer of Cassandra, so no more master. And the Solr index are replicated the same way as the original data of Cassandra, so same replication factor. So no more master. So you have a masterless Solr.
There's no zookeeper involved.
There is no master. No master, no zookeeper. So in fact, the combination of both of them is better than the Solr alone.
Yeah.
Yes.
And what happens if Spark master fails?
Ah, you are introducing the next slide. Thank you. It's great. Those people are great. Oh, I'm running out of time, sorry. Just a very quick demo. So here, the same query using Spark SQL and Solr. I want to have all album release of American artists having style rock after 2010. So complex query, blah. I don't know how long it takes. 5 seconds. Display result. Here. See? 5 seconds. So if you are restrictive enough, you can hope to do it near real time. Last things. Zookeeper. Spark master slave. You want high availability, you need to pull in Apache Zookeeper, right? But we introduced a new general leader election framework. We use gossip and failure detector from Cassandra to detect when a node is down. And we use lightweight transaction for leader election. So what is the idea? I said it before, the Spark Master is a very small process, requires very few resources. We embed the Spark Master inside the same JVM as a one DSE. Okay? And since it is in the same JVM as one of the DSE on the cluster, we use Cassandra Gossip to detect failure, lightweight transaction for master election. So with this, we no longer need Zookeeper. And this election framework can work with any master-slave architecture. Tomorrow, we can, for example, integrate Apache Kafka, right? There is a master. We put the master of Kafka inside one of the JVM of DSE, and we use the same primitives. Questions? Yes?
Solr, how much it increases the disk space, the use of Solr into the Cassandra, or it does everything in memory, or it keeps indexes in memory?
No. The index of Solr are still using index written on disk. But what we did is we optimized. First, you know that Solr, they have a write ahead lock. Okay? We remove it because we have Cassandra commit lock first. Second, you know that with Solr or Elasticsearch or whatever, or you can save the index or the source. We remove the source because the source are in Cassandra, so we only save the index. Any other question? Yes.
I have a question about Solr indexes. Sorry, it's okay. Short hold. It's super interesting. The thing is that Solr, when it builds the indexes, it will of course consume memory and resources, and of course we know all about that. Some people say that in fact you should periodically kind of purge Solr and restart again after you've done many transactions on your Cassandra.
Restart the core.
What is your opinion on that? Because I mean, an indexer is a very different search system than Cassandra.
I don't know how the team they solve this problem. To be honest, I'm not expert enough with Solr. I know a little bit. I know how it works. I know, but not to that level deep. One question. Okay, finish. You can ask me a question later if